Today we're back in section 6.2. We're going to be looking at page 378, check your understanding. This problem is going to focus more on combining random variables, whereas the last problem focused on transforming random variables. So a large auto dealership keeps track of sales and lease agreements made during each hour of the day. Let X equal the number of cars sold and Y equal the number of cars leased during the first hour of business on a randomly selected Friday. Based on previous records, the probability distributions of X and Y are as follows. And you can see there the breakdown for cars sold, which is our X, and cars leased, which is our Y. Now we're going to define a new variable D as the difference of X and Y. And we're going to assume that X and Y are independent. Let's slide this up so you can see it a little bit better. There should be good for you. Okay, so if we look, sorry, I'm trying to reveal these things one thing at a time. All right, so we're going to find and interpret the mean of D. Now to do this, we want to use the formula for it, which is on page 376. On page 376 in the yellow box under the blue header that says mean of the difference of random variables. It says for any two random variables X and Y, if D equals X minus Y, then the mean of D is mu of D equals mu of X minus mu of Y. So that's what we're going to be using. Again, this is one of those formulas you have to memorize. It won't be given to you in the resource packet. So now plugging in the values that we know, mu of X is 1.1 and mu of Y is 0.7. So we get the mean of the difference is going to be 0.4. The other part of this question asks us to interpret what the mu of D is. So notice since we have a positive number, that means that the mu of X would have had to have been larger than the mu of Y. So that tells us the average number of cars sold is larger than the average number of cars leased. So to put that into words, we find over many Fridays, this dealership sells about 0.4 cars more than it leases during the first hour of business on average. Then going on to number 2, it says to compute the standard deviation of D and show your work. Again, to look for the formula, it's on page 377. Just give you guys reference points here. This was page 377. Again, you're going to look at that yellow box. There's a blue header that says variance of the difference of random variables. For any two independent, and that's why it was important for them to have told us it was independent here, two independent random variables, X and Y, if D is equal to X minus Y, then the variance of D is sigma squared of D, which remember means variance, is equal to sigma squared of X plus sigma squared of Y. As soon as you're combining two random variables, you're always introducing more variability. So you're always going to be adding them. Whether it's a difference up here or a sum up here, this is always going to be a sum because you're adding additional variability. So we are going to take, in this case, our standard deviations, which was 0.943, and square that, plus the standard deviation of the second one was 0.64, and square that, and we get 1.2998. So if we're going to compute the standard deviation of D, we're going to take that variance that we just calculated and get the standard deviation by taking the square root of that. So 1.2998, if we take the square root of that, we get 1.14. So the standard deviation of this difference is 1.14. And yes, as always, make sure you are showing work just as I am. All right, and moving up to our last question. It says the dealership's manager receives $500 bonus for each car sold and a $300 bonus for each car leased. Find the mean and standard deviation of the difference in the manager's bonus for cars sold and leased. And it wants us to show our work. Okay, so now we're going to be combining the ideas of both transforming random variables and combining random variables. So we're going to take the formulas on page 366 for multiplying by a constant, and we're going to put it together with what we just got done doing on number 1 and on number 2. So our mean of this new random variable, let's call this new random variable B, where it stands for our bonus. So this is our bonus that the manager is receiving. So we're going to say the mean of B is equal to, we're going to take that multiplier times the mean. Then we are going to subtract, just like we did up here, the multiplier times the second mean, which was 0.7, and that's going to give us a mean for this manager of $340 with his bonus. And then to get to the standard deviation, remember we're first going to go to variances. So for the variance, remember for the variance, or for the standard deviations, we multiplied as well. So we're going to take 500 times the standard deviation, which is 0.943. Now this is going to be the standard deviation of x after it has the bonus applied to it, and we're going to square those to get the variance of that random variable. And again, always adding for variance, we're going to take the standard the multiplier of 300 times the standard deviation was 0.64, and we're going to square that, so that way it's a variance. So essentially you're squaring 500 and squaring 0.943, squaring 300 and squaring 0.64. And that all multiplied and worked out together is going to give you 259,176.25 for our variance. But again, we are going to change that into a standard deviation. Let me move so you can see me. By taking the square root, and that is 259,176.25 is going to now equal $509.09. So again, really just keeping track of all those different rules and formulas. Make sure you're really studying these. Maybe do flashcards or something to help you study them all.